All right, welcome to Chapter 8. We're going to have a look at more about processing data in this chapter. And here are some of the topics we're going to look at. We're going to spend a lot of time focusing on how to look at string and character processing. And we've looked at strings a little bit, but we're going to dive into that a little bit deeper and look at individual characters. And we use this a lot when we're trying to retrieve inputs from the user, and we can really break it apart to test it. Structs, enumerated types, and image list controls are all part of Chapter 8. So we're going to start off with looking at a variety of different string and character processing techniques in this chapter. A structure, which is a concept that we're going to be using actually and building on in Chapter 9, which allows you to encapsulate, they say here, several variables into a single item, almost like an array if you think about it. But it's by putting in a lot of different variables. And enumerated types, these are data types that you can actually create yourself. So like instead of an int or a string or double, we're going to make an enumerated type and do one ourselves. And then finally we'll look at an image list control, which is kind of like a series of images all kind of listed out, very similar to an array concept as well. Alright, so the string and character processing, we're going to be taking data into our systems, and text data or string data, and when we do that we want to be able to manipulate that string at a very detailed level, at a very singular character level. And the .NET framework, C# does provide these tools to allow us to break it down, and this is a new data type that we're going to look at called the char. We've looked at a lot of the string, but now we're going to get into a little more about the individual characters in this chapter. So the char type is not very complicated. In fact, you might have almost thought we could have talked about this in earlier chapters. And it's a data type similar to almost a string, but we're just dealing with one single character. That's why they call it a char. And it varies slightly from the string because we only have one character, and we initialize it a little bit differently. So here in the example, we initialize a char data type here called letter, and we want to assign the letter G to it. We use a single quotes rather than double quotes. Double quotes is reserved for strings. The char is also a value type. So when we declare the letter, in this example, we assign a value of G. It puts in 1G and loads that into the stack, and we refer to that as a single character. So the reason that the char and the string are incompatible is because the char is a value type and the string is a reference type, and they're handled differently in the memory and what we can do with them. And we'll dive into that a little bit further now that we're talking about this. So in this example here, if we used, let's take letter, which was initialized as a char, and we type in, let's assign the letter G, initialize it, but with double quotes, that's going to throw an error because the compiler assumes that you're trying to assign a string to a data type, and that's just not going to work. So that'll throw back an exception. Alright, now if you did want to convert it, of course we have our method here called the to the string. So if we did initialize it with a single quote and we had the letter G in here, we could send it into a string and output that in example into a message box. So we can manipulate into a different type if we use the method here called to a string. Now if you take a look at a string that we've looked at in the past here, let's say we use the word Jacob here and we assign it to a string here called letter. That's referred to as a reference type, and of course char now is a value type. So if we were to look at this at a closer look at the string, we can actually pull apart a string by using its subscript, just like an array. If you think about a string, it is actually like an array. Like the J is stored separately, then the A is stored separately from the C, and so on. So each of those are stored in their own separate subscripts. So you can see in this example here, if we had Jacob, we could actually put in index and access the subset, the subscript, and we could pull it apart. So this would display the letter J and then another message box for the letter A, C, B, and O and B. So it'll actually walk through that entire string and display every character step by step, because it's actually in something that's very similar to an array. And we could use this one here called for each, and this is the one we'll probably be using from this point on.